Hi guys, today our group would like to share about vertical displacement measurement of vehicle body in suspension system. So, the importance of the vertical displacement measurement of suspension has three categories, which is comfort, safety and performance. They will include about vibration reduction, passenger experience, stability control, predictive components, and ride quality and the vehicle dynamic. Okay, for performance, the ride quality is for the damping performance where the accurate measurement of vertical displacement help in tuning the suspension damper to provide optimal damping characteristic. For the suspension tuning is for data for the vertical displacement to adjust the spring rate and the suspension of the geometry. For the vehicle dynamic, the load transfer is to understanding vertical displacement to help to analyze the load transfer during acceleration, brake or cornering. For the safety, the stability control has ESC, electronic stability control, to accurate vertical displacement to feed into the data into the ESC, allow to make adjustment to braking and throttle input to maintain the vehicle stability. And the TSC is traction control system to optimize grip by adjusting the torque amongst the wheel. And for the predictive maintenance, we get the early sign of the component wear such as absorber and spring. For the comfort, the vibration reduction get a smooth ride by measuring and controlling the vertical displacement, leading a smoother, comfortable ride for the passenger. For the noise reduction, reducing road noise transmit through the suspension. And lastly, for the passenger experience, minimize body motion, properly tune the suspension system based on the vertical displacement data to minimize excessive body movement such as bouncing and swaying, to providing a more pleasant travel experience.
The specific type of transducer that we choose in this project is piezo-resistive accelerometer. Why we choose this? This is few criteria that we need to look, we need to study for the selection, such as the frequency response, the cost, the temperature stability. So I'm going to give you few examples, few comparison why we choose this type of transducer. So piezo-resistive accelerometer, they are favored for their high frequency, high sensitivity and robustness in detecting low frequency vibration, making them ideal for detailed vibration analysis. But they tend to be more expensive and bulkier compared to other types. MEMS accelerometers are compact and cost-effective, providing sufficient sensitivity for many applications. But the problem is they may not match the precision like a piezo-resistive accelerometer. Hence, while other may offer low cost, by taking the performance benefit into consideration, piezo-resistive accelerometer is the preferred choice for high-stake and high-precision application.
So now let us go through the working principle of accelerometer. For the basic mechanism of piezo-resistive accelerometer, it consists of piezo-resistive effect and mass spring system. Relies on piezo-resistive effect, where the resistance of material changes under mechanical strain. The acceleration causes strain in the piezo-resistive element, altering their resistance and producing a measurable voltage change. Inside the accelerometer, there is small mass attached to a spring. When a vehicle undergoes acceleration, the accelerometer experiences acceleration and causes the mass move relative to its housing. The movement of the mass causes mechanical stress in the piezo-resistive elements integrated into beam or diaphragm. Next, we proceed with converting acceleration into electrical signal. Bridge circuit. So a key component in piezo-resistive accelerometer is whetstone bridge circuit. The piezo-resistive elements are configured in a whetstone bridge circuit. This configuration helps in measuring small changes resistance with high accuracy. After the bridge circuit, we then go through the output voltage. When acceleration causes stress on the piezo-resistive elements, the resistance change unbalances the whetstone bridge, resulting in a differential output voltage that is proportional to acceleration. So lastly, the signal conditioning. It is a crucial process in converting the raw electrical signal from a piezo-resistive accelerometer into a usable form. So the two processes that could be used to complement our accelerometer are amplification and filtering process. Okay, now I will explain about the principle of converting acceleration data into displacement. The first integration is to integrate the output voltage, which is proportional to acceleration over time to obtain velocity. After that, we will integrate the calculated velocity over time to determine displacement in our second integration. So that is all from me. Thank you.
Okay, next I will be presenting about the advantages and disadvantages focusing on the piezo-resistive after we make it an relevant consideration between all the possible transducers which involved in the accelerometer. So the first advantages of the piezo-resistive is it capable in high overload capacity, which are relevant to apply in our case, which is in the suspension system of the car. So the second one is the wide frequency response, which it can measure both static and the dynamic acceleration. So the third is it was durability and the longevity. So it means that it can provide the reliable performance over a long period. And the last one is it good in the DC response. Disadvantages of this type accelerometer is it use high power consumption, which potentially impacting the battery life of the car. Second one is it is low sensitivity at a low frequency rather than a capacitor, which it can be measured in low frequency. The last one, it has a bad temperature sensitivity, which is it can be affected by the temperature change, and it can be lead the output itself in a wrong measuring. Okay, next I will give an example of the accelerometer specification, which a model itself has already in the market. So based on the catalog that I provided in the slide, it claimed that the accelerometer use advanced NEMS technology for the ruggedness and stability and reliability. Other than that, it also integrated by mechanical stop and the damping. Based on the specification provided in the catalog, the first one is it has the 2 active arm and the full bridge circuit, which help to simplify the calibration process. The second one is the full scale output itself given is a 400 millivolt output when the excited within a 10 volt DC power supply. The last one is the full scale stated that it range of the 1000 G. The G itself is defined as the acceleration of the gravitational acceleration. As example, if we select a plus minus 20 G accelerometer, so it means that it can measure a vertical acceleration between the minus 20 G and to plus 20 G, which translate to the range of the plus minus 196.2 milli per second squared. It also stated that it is less than 1% of the Fender sensitivity and less than plus minus 25 millivolts, a zero measurement output.
Okay, we go to the mounting and installing a pressure safety accelerometer on car suspension. For the first of all, we must select of mounting location on the suspension. For the criteria is choose a location that experience direct suspension movement, such as near the shock absorber or on the control arm. The mounting surface should be rigid to avoid flexing. Align the accelerometer to measure the desired axis of motion. For example, vertical movement for up and down suspension dynamics. Ensure the location is protected from road, debris, water and other environmental factors. For the secondly, we must prepare of mounting surface. Ensure the mounting surface is clean, dry and free of oils or debris. The surface should be flat to provide proper contact and adhesion. For the thirdly, we use multimeters and we use adhesive mounting. Use a strong adhesive, for example, epoxy or specialized accelerometer adhesive. Apply the adhesive evenly and press the accelerometer firmly against the surface. Allow cooling as per adhesive instruction. For the thirdly, electrical connections. Ensure connectors are compatible with the accelerometer. Road cables to avoid strain, interference and exposure to harsh conditions. Use cable ties or clips to secure cables and prevent movement. For the fifth, calibration and testing. Calibrate the accelerometer according to the manufacturing instruction. Functional testing. Test the accelerometer to ensure its operating correctly and providing accurate readings. For the sixth, environmental protection. If the accelerometer is exposed to elements, use sealants or protective enclosures. Use heat shields if the accelerometer is near high temperature components. For the seventh, data acquisition system. We use integration. Connect the accelerometer to the vehicle's data acquisition system. Configure the data acquisition system to get and record data from the accelerometer. For the last is maintenance. Periodically check the mounting integrity and connections. Regularly recalibrate the accelerometer as per the manufacturer's recommendations. Okay, for the last, for my last slide is it is a diagram. For the first diagram is a conception of system for safety accelerometer, and the second diagram is full system of physical safety accelerometer in suspension car, and the thirdly is the piezo resistive accelerometer.